self-control is the ability to control one's emotions, behavior, and desires in order to obtain some reward, or avoid some punishment. Presumably, some smaller reward or punishment is operating in the short term which precludes, or reduces, the later reward or punishment. In psychology it is sometimes called self-regulation. In behavior analysis, another view is that self-control represents the locus of two conflicting contingencies of reinforcement, which then make a controlling response reinforcing when it causes changes in the controlled response. Self-control research. Human and non-human self-control. Human self-control research is typically modeled by using a token economy system in which human participants choose between tokens for one choice, and using obtained for humans and non-humans, clarification needed, with the latter appearing to maximize their overall reinforcement despite delays, with the former being sensitive to changes in delay. The difference in research methodologies with humans, using tokens or conditioned reinforcers, and non-humans using subprimary forces suggested procedural artifacts as a possible suspect. One aspect of these procedural differences was the delay to the exchange period, Hyten and others 1994. Non-human subjects can, and would, access their reinforcement immediately. The human subjects had to wait for an exchange period in which they could exchange their tokens for money, usually at the end of the experiment. When this was done with pigeons they responded much like humans in that males had less control than females, Jackson and Hackenberg 1996. However, Log, 1995, who is discussed more below, points out that in her study, done on self-control, it was male children who responded with less self-control than female children. She then states that in adulthood, for the most part, the sexes equalize on their ability to exhibit self-control. This could suggest a human being's ability to exert more self-control as they mature and become more aware of the consequences associated with impulsivity. This suggestion is further examined below. Most of the research in the field of self-control assumes that self-control is in general better than impulsiveness. Some developmental psychologists argue that this is normal, and people age from infants, who have no ability to think of the future, and hence no self-control or delayed gratification, to adults. As a result, almost all research done on this topic is from this standpoint, and very rarely is impulsiveness the more adaptive response in experimental design. More recently, some in the field of developmental psychology have begun to think of self-control in a more complicated way, that takes into account that sometimes impulsiveness is the more adaptive response. In their view, a normal individual should have the capacity to be either impulsive or controlled depending on which is the most adaptive. However, this is a recent shift in paradigm and there is little research conducted along these lines. Skinner's Survey of Self-Control Techniques. B.F. Skinner's Science and Human Behavior provides a survey of 9 categories of self-control methods: physical restraint and physical aid. The manipulation of the environment to make some response easier to physically execute, and others physically more difficult, illustrates this principle. Things such as clapping one's hand over one's own mouth, placing one's hands in one's pockets to prevent fidgeting, and using a bridged hand position to steady a pull shot all represent physical methods to affect behavior. Changing the stimulus. Manipulating the occasion for behavior may change behavior as well. Removing distractions that induce undesired actions, or adding a prompt to induce it are examples. Hiding temptation and reminders are 2 more. Depriving and satiating. One may manipulate one's own behavior by affecting states of deprivation or satiation. By skipping a meal before a free dinner, one may more effectively capitalize on the free meal. By eating a healthy snack beforehand, the temptation to eat free junk food is reduced. Manipulating emotional conditions. Going for a change of scene can remove emotional stimuli, as may rehearsing injustice, to motivate a strong response later. Treating an activity as work or fun can have an effect on the difficulty of self-control. Using aversive stimulation. Setting an alarm clock to awake ourselves later is a form of aversive control. By doing this, we arrange something that will only be escapable by doing things, turning off the clock, which tend to awaken ourselves. Drugs. The use of self-administered drugs allows us to simulate changes in our conditioning history. The ingestion of caffeine allows us to simulate a state of wakefulness which may be useful for various reasons. Operant conditioning. The use of the token economy, or other methods or techniques unique to operant conditioning, may be seen as a special form of self-control. It can take great self-control to stay off drugs or to stop smoking. Punishment. Self-punishment of responses would include the arranging of punishment contingent upon undesired responses. This might be seen in the behavior of whipping oneself, which some monks and religious persons do. This is different from aversive stimulation in that, for example, the alarm clock generates escape from the alarm, while self-punishment presents stimulation after the fact, to reduce the probability of future behavior. Punishment is more like conformity than self-control, because with self-control there needs to be an internal drive, not an external source of punishment, that makes the person want to do something. There is external locus of control which is similar to determinism, and there is internal locus of control which is similar to free will. With a learning system of punishment, the person does not make their decision based upon what they want, rather they base it on the external factors. When you use a negative reinforcement, you are more likely to influence their internal decisions, and allow them to make the choice on their own, whereas with a punishment the person will make their decisions based upon the consequences, and not exert self-control. The best way to learn self-control is with free will, where people are able to perceive they are making their own choices. Doing something else. Skinner noted that various philosophies and religions exemplified this principle, by instructing believers to love their enemies. When we are filled with rage or hatred, we might control ourselves, by doing something else, or more specifically something that is incompatible with our response. Brain regions involved in self-control. Functional imaging of the brain has shown that self-control is correlated with an area in the dorsolateral prefrontal cortex, DLPFC, a part of the frontal lobe. This area is distinct from those involved in generating intentional actions, attention to intentions, or select between alternatives. This control occurs through the top-down inhibition of premotor cortex. There are many researchers working on identifying the brain areas involved in the exertion of self-control. Many different areas are known to be involved. At the biological level, a loss of control is thought to be caused by a malfunctioning of a decision mechanism. A mechanistic explanation of self-control is still in its infancy. However, there is strong demand for knowledge about these mechanisms, because knowledge of these mechanisms would have tremendous clinical application. Much of the work on how the brain reaches decisions is based on evidence from perceptual learning. Many of the tasks that subjects are tested on are not tasks typically associated with self-control, but are more general decision tasks. Nevertheless, the research on self-control is informed by more general research on decision tasks. Sources for evidence on the neural mechanisms of self-control include free studies on human subject, neural recordings on animals, lesion studies on humans and animals, and clinical behavioral studies on humans with self-control disorders. There is broad agreement that the cortex is involved in self-control. The details of the final model have yet to be worked out. However, there are some enticing findings that suggest a mechanistic account of self-control could prove to have tremendous explanatory value. What follows is a survey of some of the important recent literature on the brain regions involved in self-control. Prefrontal cortex. Todd A. Hare and others use functional MRI techniques to show that the ventromedial prefrontal cortex, VMPFC, and the dorsolateral prefrontal cortex, DLPFC, are crucially involved in the exertion of self-control. They found that activity in the VMPFC was correlated with goal values, and that the exertion of self-control required the modulation of the VMPFC by the DLPFC. The study found that a lack of self-control was strongly correlated with reduced activity in the DLPFC. Hare's study is especially relevant to the self-control literature, because it suggests that an important cause of poor self-control is a defective DLPFC. Outcomes as determining whether a self-control choice is made. Alexandra W. Log is interested in how outcomes change the possibilities of a self-control choice being made. Log identifies three possible outcome effects: outcome delays, outcome size, and outcome contingencies. The delay of an outcome results in the perception that the outcome is less valuable than an outcome which is more readily achieved. The devaluing of the delayed outcome can cause less self-control. A way to increase self-control in situations of a delayed outcome is to pre-expose an outcome. Pre-exposure reduces the frustrations related to the delay of the outcome. An example of this is signing bonuses. Outcome size deals with the relative, perceived size of possible outcomes. There tends to be a relationship between the value of the incentive and the desired outcome. The larger the desired outcome, the larger the value. Some factors that decrease value include delay, effort/cost, and uncertainty. The decision tends to be based on the option with the higher value at the time of the decision. Finally, log defines the relationship between responses and outcomes as outcome contingencies. Outcome contingencies also impact the degree of self-control that a person exercises. For instance, if a person is able to change his choice after the initial choice is made, the person is far more likely to take the impulsive, rather than self-controlled, choice. Additionally, it is possible for people to make pre-commitment action. A pre-commitment action is an action meant to lead to a self-controlled action at a later period in time. When a person sets an alarm clock, they are making a pre-committed response to wake up early in the morning. Hence, that person is more likely to exercise the self-controlled decision to wake up, rather than to fall back in bed for a little more sleep. Cassandra B. White studied locus of control and academic performance, and determined that internals tend to achieve at a higher level. Internals may perceive they have options from which to choose, thus facilitating more hopeful decision-making behavior as opposed to dependence on externally determined outcomes that require less commitment, effort, or self-control. Physiology of behavior. Many things affect one's ability to exert self-control, but it seems that self-control requires sufficient glucose levels in the brain. Exerting self-control depletes glucose. Reduced glucose, and poor glucose tolerance, reduced ability to transport glucose to the brain, are correlated with lower performance in tests of self-control, particularly in difficult new situations. Alcohol causes a decrease of glucose levels in both the brain and the body, and it also has an impairing effect on many forms of self-control. Furthermore, failure of self-control occurs most likely during times of the day when glucose is used least effectively. Self-control thus appears highly susceptible to glucose. An alternative explanation of the limited amounts of glucose that are found is that this depends on the allocation of glucose, not on limited supply of glucose. According to this theory, the brain has sufficient resources of glucose, and also has the possibility of delivering the glucose, but the personal priorities and motivations of the individual cause the glucose to be allocated to other sites. This theory has not been tested yet. The Mischel paradigm. In the 1960s, Walter Mischel tested 4-year-old children for self-control in the marshmallow test. The children were each given a marshmallow, and told that they can eat it anytime they want, but if they waited 15 minutes, they would receive another marshmallow. Follow-up studies showed that the results correlated well with these children's success levels in later life. A strategy used in the marshmallow test was the focus on hot and cool features of an object. The children were encouraged to think about the marshmallow's cool features such as its shape and texture, possibly comparing it to a cotton ball or a cloud. The hot features of the marshmallow would be its sweet, sticky tastiness. These hot features make it more difficult to delay gratification. By focusing on the cool features, the mind is adverted from the appealing aspects of the marshmallow, and self-control is more plausible. Years later, Dr. Mischel reached out to the participants of his study who were then in their 40s. He found that those who showed less self-control, by taking the single marshmallow in the initial study, were more likely to develop problems with relationships, stress, and drug abuse later in life. Dr. Mischel carried out the experiment again with the same participants, in order to see which parts of the brain were active during the process of self-control. The participants received scans through MRI to show brain activity. The results showed that those who exhibited lower levels of self-control had higher brain activity in the ventral striatum, the area that deals with positive rewards. Reviews concluded that self-control is correlated with various positive life outcomes, such as happiness, adjustment, and various positive psychological factors. Self-control was also negatively correlated with sociotropy, which in turn is correlated with depression. Ego depletion. Ego depletion. Exerting self-control through the executive functions in decision-making is held in some theories to deplete one's ability to do so in the future, to deplete one's ability to do so in the future, to deplete one's ability